Charles' law. Charles' law states that if a given quantity of gas is held at a constant pressure, its volume is directly proportional to the absolute temperature. Think of it this way. As the temperature of the gas increases, the gas molecules will begin to move around more quickly and hit the walls of their container with more force. Thus, the volume will increase. Keep in mind that you must use only the Kelvin temperature scale when working with temperature in all gas formulas. Here's the expression of Charles' law that you should memorize. V1 over T1 is equals to V2 over T2.
Boyle's law is an experimental gas law that describes how the pressure of gas tends to increase as the volume of the container decreases. A modern statement of Boyle's law is the absolute pressure exerted by a given mass of an ideal gas is inversely proportional to the volume it occupies if the temperature and the amount of gas remain unchanged within a closed system. Mathematically, Boyle's law can be stated as P multiplied by V equals to K.
In a demonstration of Boyle's law, we'll place a balloon in a vacuum bell jar. We'll apply a vacuum which basically pumps out the air in the bell jar. The pressure outside the balloon will be greater than the pressure inside. The balloon expands to try and equalize the pressure. Volume and pressure are inversely related to each other. When we release the vacuum, the pressure increases and the volume decreases. As another demonstration of Boyle's law, we will put a marshmallow peep into our vacuum jar. The marshmallow contains air trapped in a mixture of gelatin and sugar. As we apply the vacuum, the pressure outside is lower than the pressure inside. The air in the peep will expand to try and equalize the pressure. When we release the vacuum, the pressure increases and the volume decreases. As another illustration of Boyle's law, we will put some shaving cream into our vacuum jar. The shaving cream contains air trapped in a soap mixture. As we apply a vacuum, the pressure outside is lower than the pressure inside. The shaving cream will expand to try and equalize the pressure. As you decrease the pressure, the volume increases.
Gay-Lussac's law. This law is often referred to as Gay-Lussac's law of pressure temperature. Between 1800 and 1802, discovered the relationship between the pressure and temperature of a fixed mass of gas kept at a constant volume. Gay-Lussac discovered this while building an air thermometer. The pressure of a gas of fixed mass and fixed volume is directly proportional to the gas absolute temperature. If a gas temperature increases, then so does its pressure if the mass and volume of the gas are held constant. The law has a particularly simple mathematical form if the temperature is measured on an absolute scale, such as in kelvins. The law can then be expressed mathematically as P over T is equals to K.
Will remain constant, and when temperature increases, pressure will decrease, and also when temperature increases, pressure will increase. For this law, I will show you a demonstration. The demonstration works like this. First, I placed 4 candles on a plate and poured water onto the plate. Then, I lit the candles and put a glass upside down over the candles. What happens in this demonstration is by putting the glass over the burning candles, the temperature decreases and also the pressure increases. By the pressure increasing, it pulls the water into the cup, and when there's no oxygen left, the candles burn out. The cup makes a slight vacuum seal, keeping the water in the cup. This is a simple and fun demonstration of Gay-Lussac's law that can easily be done at home in 4 simple steps.
That's just how I feel. That's just how I feel. Trying to reach the things that I can't see. Am I tripping for having a vision? My prediction, I'ma be on top of the world. Walk, don't look back. Always do what you decide. Don't let them control your life. That's just how I feel. Oh, fight for yours, so don't let go. Don't let them compare you, no. Don't worry, you're not alone. That's just how we feel. Am I wrong? Am I wrong for thinking that we could be something for real? Oh yeah. Oh, now am I wrong? Am I wrong for trying to reach the things that I can't see? Oh yeah. That's just how I feel. That's just how I feel. That's just how I feel. Trying to reach the things that I can't see. If you tell me I'm wrong, I don't wanna be right. If you tell me I'm wrong, I don't wanna be right. If you tell me I'm wrong, I don't wanna be right. If you tell me I'm wrong, I don't wanna be right. Am I wrong for thinking that we could be something for real? Now am I wrong for trying to reach the things that I can't see? But that's just how I feel. That's just